Hello, good morning to all of you. How are you, student? I hope you all are happy, healthy and fine at home. What did we discuss yesterday? Yesterday we discussed about the electrophilic addition reaction of halogen atom, or what we can call it as a halogenation reaction. And halogenation reaction, it is one of the classical method for identification of unsaturation of the organic compounds. So that we have seen by taking various examples. We have seen, or we have discussed that mechanism. What we are going to learn today, or what we are going to discuss today, we learning or studying the chapter number 4, reactions of unsaturated hydrocarbons and carbon oxygen double bond. So here addition of hypohalous acid HOX, when they form HOX, there will be HO gets minus delta charge, minus partial delta charge, whereas X means that halogen always gets the partial positive charge, and this reaction is known as halohydrine formation. Halohydrine formation, halohydrine, it is a derivative obtained when it is treated with the alkene. So that is thing over there. Now in this reaction also as a electrophilic addition reaction, when the alkene reacts with chlorine in presence of water, gives the halohydrine derivative, and this reaction specifically, or this reaction also simply mix with alkene and the reagent, and we are getting as a addition reaction. The addition reaction takes place according to the Markovnikov's rule. Here HO and X, halogen atom is acting as a plus charge over there, and HO is a negative charge. So as we know that according to as a Markovnikov's rule, statement of Markovnikov's rules says that in an addition reaction, negative part of the reagent or addendum attached to those carbon atom which carries less number of hydrogen atom. And now what type of the, let us see one of the simplest example, and we generally considering the one example always there which is unsymmetrical in nature, that is CH3 CH double bond CH2. That is a propylene we generally considering in this case, and then it is treated with this Cl2 in presence of water H2O. What does it give? The product form which is according to as a Markovnikov's rule, CH3 CH OH CH2 and here chlorine atom Cl. Now this is the product we are getting. The whatever atom of that is completely get consumed over there, and we are getting as a this type of the product. What will be the RUHC name of this compound? Look at here the RUHC name of this compound. Give the number from this side, from right hand side, 1 2 3, right? 3 carbon atom in the straight chain. At one position chlorine atom is there, and therefore 1 chloro 2 propanol. 2 propane indicate as a 3 carbon atom in the straight chain, therefore 2 propanol. OL indicate as a last suffix or the prefix OL clearly indicate that is a alcohol is present over. So this is a RUHC name of this compound, and this reaction takes place according to as a Markovnikov's rule. Now let us look at the mechanism of this reaction. Mechanism, as we know that it is a language of organic chemistry, and therefore according to the mechanism, how the mechanism takes place, let us see here. First step, what is happening, Cl2 that will be treated with water, chlorine gas pass through that water. What is going to happen? You are going to get HO, Cl and plus HCl. HCl fumes that goes in the atmosphere, and this is a hypochlorous acid is formed. Here hypochlorous acid hydroxyl group gets partial negative charge, whereas we know that the tendency of that chlorine atom, but here it shows or it gets plus delta charge. It shows as a pseudo interhalogen type of the not what we can call it as a pseudo halogen atom, like as a halogen. So they can show positive as well as negative, and therefore this is a charge present on it, and this is the first step. And in the second step, what is happening? And as usual, CH3 CH double bond CH2, this is a reagent. The name of this reagent is a hypohalous chloride, hypochlorous acid, hypochlorous acid. This is the name of the reagent, hypochlorous acid. And then H, here you can write for sake of convenience Cl over here and OH in this way. Now here is a plus delta charge, here should be the minus delta charge. As we know that this is a act as nucleophilic in nature, so it is going to attack on that chlorine atom. OH is a living group, so that you are going to get here, this step is a RDS, rate determining step, slow step, where there is a formation of this one CH2Cl. When chlorine attached over there, when this double bond moves this side, forming as a bond with that chlorine atom, what type of the charge present on this carbon atom? There must be positive charge on the carbon atom. When positive charge present on this carbon atom, this is formed as a short interleave, and the name of this cation is a carbocation. You can call it as a carbocation, or the another name of this species is a carbonium ion. Now in the second step, what is happening? Second step is a fast step over here. OH minus, it is a fast step, and that OH is attacked to that carbonium ion, and the product form is this one CH3 CH OH CH2 and the Cl. So this is the product which we have seen in the above general reaction. So in this there are the two steps are there. First step is a formation of the carbonium ion, and second one is a very fast step. In the first step we cannot determine the rate of the reaction. So that type I think something is let me clear, something is let us see here is not the intermediate. Carbocation formation is a not intermediate, similar to as a what we can call it as a bromination or chlorination. There we have seen there is a formation of this cation. Here is a chlorine atom, that is a cyclic chloronium ion is formed there, 3-membered ring. So remember here, this is a 3-member ring is formed there, CH3. This is called as a cyclic chloronium ion. Chloronium ion In the previous case, just now we have seen carbonium ion, that is not there, but actually what the scientists found, when hypohalous acid react with that alkene, they form the cyclic chloronium ion. That cyclic chloronium ion 3-membered ring is a very unstable, and now then attack of OH minus. And remember here, this is first step. In the second step, what is happening here? CH3, CH, then CH, CH2, chlorine atom, positive charge over there, and now OH minus. Remember, this OH minus attack to those carbon, it is attacking, there are 2 carbon atoms are there, where this nucleophile can attack. And remember, OH is going to attack at this carbon atom or at this carbon atom. Here always remember, OH minus always in this particular reaction, OH minus attack to the more substituted carbon atom. Remember here, look at this carbon atom and this carbon atom. This carbon atom is a more substituted carbon atom, because here is a methyl group, here is a 2 hydrogen atom, and therefore hydrogen atom, this hydroxyl ion OH minus should attack to the more substituted carbon atom, and this 3-membered ring get opened, and you are going to get the formation of the product is this one, CH3, then CH, here OH, and this CH2Cl. The name of this compound is this we already learned here. So remember this mechanism proceeding via cyclic halonium ion. If chlorine is there, cyclic chloronium ion. If bromine is there, cyclic bromonium ion. This type of the product we generally form there. Here first step is a formation of the hypohalous acid. In the second hypohalous acid, that reagent is attacked in a rate determining step, which is a slow reaction, where we can find out the how much time is required to complete that reaction. And in the third step, what is happening? OH, the stereochemistry here, remember the OH attached to the more substituted carbon atom, and therefore we are going to get as a product is this one. Later there are 2 steps. First one is a formation of the halonium ion, and second one is the attack of the OH. And in this way we have seen the example what is addition of the hypohalous acid. This and whatever these derivatives form, that derivative name of that derivative is halohydrin formation. This is a hydrohalline formation just now we have seen. And here the first step involve the formation of the cyclic halonium ion. Now let us look at as some of the example. From that you can understood the meaning of this. Now just now we have seen one suitable example for this reaction. I don't think you will forget forever this type of the reaction if there is predict the product here. So predict the product, remember, if you know the mechanism, then and then you can predict the reaction. Prediction means what? Just like as a geography people, by looking the cloud in the atmosphere, they are saying whether the rain today will rain or not. By this way, if you are knowing the mechanism, then and then you can predict the product very perfectly. Otherwise it is very difficult to predict the product. Predict the product means you must know the mechanism behind it. If you know the mechanism, we can able to predict. Just now we have seen as a mechanism. Now you just predict the product. I am going to give different type of the example here. you have to answer the question, right? Now let us see here one more example. Suppose we have CH3, then here CH3 double bond CH2, that will be treated with, let us see here, Br2 in presence of water, H2O, Br2 in presence of water, remember. Now what is going to happen here? Hypobromous acid is going to form, and this reaction takes place according to as a Markovnikov's rule. The negative part of the addendum or the reagent attached to those carbon which carries the less number of hydrogen atom. So that look at here, this is a carbon atom and this is a carbon atom. Look at only this part is a olefinic part, and therefore either this carbon atom or this carbon atom, here no hydrogen atom, here are two hydrogen atom. Negative part, what type of the negative? Hypohalous acid means here what type of the compound you are going to get? Here you are going to form HO Br line, right? And here we know that Br is minus delta charge, sorry, HO is a minus delta charge, Br gets a plus delta charge, and therefore where the HO is going to attach? At the middle one. Now first of all, tell me the correct IUPAC name of this compound. There are the 3 carbon atom in the straight chain. At 2 position there is a methyl group, and therefore the IUPAC name of this compound is a 2-methyl 1-propene, right? 2-methyl 1-propene, or you just call it 2-methyl propene, that's it. To mention one or not, it doesn't matter, but you remember last suffix E and E clearly indicate there is a carbon-carbon double bond present in the organic compound. Now we are predicting as a product only. We know the mechanism, and that's why we can predict the product very easily. And here CH3, then here CH3, here OH, and now CH2, and here you can write Br, you can write either this side or this side, doesn't matter, but this is the what we can call it as a product here. Can you tell me the correct IUPAC name of this compound? Do you know that? Yes, the numbering should be from left hand side or right hand side. Can you tell? Can you suggest me? Yes, it should be from the right hand side, because there is a bromine atom over there. So 1, 2 and 3, at one position there is a bromo, so 2 bromo. Then at 2 position methyl group is there, 2 methyl. At 2 position hydroxy group also there, and therefore 2 propanol. Propane means in the straight line there is a 3 carbon atom, and therefore the correct IUPAC name is a 1 bromo 2 methyl 2 propanol, right? Now let us see another example. This is a example number 1. Example number 2, let us see here. You just predict the product CH3, then CH double bond CH3, then CH3 here, then treat with Cl2 in presence of water. Now tell me what will be the product. Do you know the IUPAC name of this compound? Yes, you know that. The numbering starting from this side or this side, from right hand side, 1, 2, 3 and 4. Look at 2 position 2 methyl, and therefore 2 methyl. At 2 position carbon-carbon double bond is there, therefore 2 butene. So this is a IUPAC name of this compound. And now here Cl2 in presence of water. Remember, Cl2 in presence of water, they form the reagent. In the first, what is that? Cl and the OH. Here should be plus delta charge, and here is a minus delta charge. And as we know that this reaction proceed via Markovnikov's rule, and therefore what is going to happen? Here negative part, where it should attach. Look at this carbon atom carries 2 methyl group. There is no hydrogen atom, but this carbon atom, you think about only these 2 carbon atom, olefinic carbon atom. About these 2 carbon atom, while where the addition reaction takes place, because there is a carbon-carbon double bond. This is unsaturated compound, and the addition reaction takes place. There is a change in hybridization. sp2 hybridization changes into as a sp3 hybridization, means unsaturated compound converted into as a saturated compound, and the hybridization go on changing, as we know that theoretically. And here we know that CH3, then CH, Cl, then CH3, and this CH3, and one bromine atom is there. Now this is the product, we get only one product. Now sorry, not this one, where the bromine, instead of that bromine there will be a OH, not the bromine, remember here. So here is a Cl and OH is going to add Cl here, OH should be there. Therefore the correct IUPAC name. Now OH and Cl, they are at 2 position. If you go from this side, 2 position, this OH from 2 position, but from here you will give the you will start the numbering should start from the right hand side, because this OH is a more oxidizable group than the halogen, and therefore numbering should be start from this side. 1, 2, 3 and 4. At 3 position chlorine atom is there, so therefore 3 chloro. At 2 position methyl group is there, 2 methyl. Then at 2 position hydroxy, therefore 2 butanol. So this is the correct IUPAC name of this compound. Now let us see one more example here. We can give the number of example. Once you know only one mechanism, you can predict millions of products, right? Because once you should remember as a mechanism. Now let us look at here another example. Here is a methyl group I am putting here, and then this will be treated with Cl2 in presence of water, EH2, right? This is a polar solvent, and if it is there, that type of the species are formed. Now remember, there is a olefinic part is this one only. This part is going to change when we are adding as a reagent, and that is called as a functional group or the site of reaction. Whenever any reagent we are adding, the part of the molecule undergoes as a change, so that type of the site is known as a site of reaction, and this functional group carbon-carbon. Now look at here, at this carbon atom, imagine is already carbon atom is there. So this is a carbon atom, here also as a carbon atom. Look at here, 1, 2, 3 and 4 bond is there, and this carbon atom has 1, 2, 3. So there is a one hydrogen atom, and therefore as we know that this Cl and OH, here is a plus delta charge, minus delta charge, and the reaction takes place according to as a Markovnikov's rule. And what the Markovnikov's rule statement tells us that the negative part of the reagent or the addendum attached to those carbon atom which carries less number of hydrogen atom. Look at this carbon atom has less number of, means there is a no hydrogen atom. Here is a one hydrogen atom, and therefore the product should be this one, and here CH3, OH, and here is a Cl. Look at, this is the product. What is the IUPAC name of this compound? There is a methyl group, so give the number from this side, 1, 2, not from this side. You should give the number from the clockwise manner here, 1, 2, 3, 4, 5 and 6. At one position methyl group is there, and therefore we can call it as a 1 methyl cycle is there. So cyclohexane, but double bond is there, so 1 methyl cyclohexene, last suffix is a ene, clearly indicate there is a carbon-carbon double bond. This is the IUPAC name of this compound, 1 methyl cyclohexene. And what is the correct IUPAC name? Again 1, 2, 3, 4, 5 and 6. At 2 position chlorine atom is there, therefore 2 chloro 1-methyl cyclohexanol. OL indicate as a alcohol group is there. So I think with this we have seen different type of the example over there, and from that I know that you are knowing now. You can predict the product very easily by this. I think with this let us stop today here. Remaining we will see in the next type, that is hydroxylation, that is the formation of 1,2-diols. Thank you. Have a nice day.